Hello and welcome back to an introduction to logic. Now I've already done a couple of videos where I covered chapter 1 in 2 parts. Now we're going to move on to chapter 2 in For All X, a open source textbook that you can download. We're using the Lorain County remix, so make sure to Google For All X, Lorain County, that's L-O-R-A-I-N. We're now on chapter 2. Now chapters 1, 2, and 3 don't get too technical, so if you're interested in learning more about sentential logic or quantificational logic, you might want to skip ahead a couple of videos, and that's okay. Right now we're still doing a very kind of introductory survey of some of the basic concepts in logic before we get too technical. All right, let's dive right into it. So I'm going to recap 2 important concepts that I've been kind of telegraphing in the last couple of videos: validity and soundness. Validity is probably the most important concept in the entire course. Now, validity has to do with the structure of an argument. It's content neutral, which means that validity has nothing to do with what the argument is about. It's what it's talking about in the world. It has to do with the structure or form of the argument. So no matter what we plug into the argument, it will remain valid. And an argument is valid if, and only if, the truth of the premises guarantees the truth of the conclusion, no matter the content. Another way to put it is that it's not possible for the premises to be true and the conclusion false. To dispute the truth of the conclusion in a valid argument is to dispute the truth of the premise itself, or one of the premises. Soundness as a concept is not content neutral. An argument is sound if it's valid and if its premises are in fact true in the world. So if I have an argument, like back in video 1, all pigs can fly, babe is a pig, therefore babe can fly, that's a valid argument. It's valid because the truth of the premises would guarantee the truth of the conclusion. If the premises are true, the conclusion is true. But the conclusion is false. Therefore, I must be disputing the truth of one of the premises. It's not, in fact, the case that pigs can fly. But if pigs could fly, could a specific pig fly? Well, yeah. That's the difference between validity and soundness. So, just again, because this is a very, very important concept here. An argument is valid if and only if the truth of the premises guarantees the truth of the conclusion. If it's impossible for the premises to be true, yet the conclusion false. An argument is sound, however, if and only if it's valid and its premises are in fact true in the world. And it's a lot easier to check validity than soundness. In fact, we're going to be developing formal techniques to verify validity in this course, but not so much soundness. That's for the scientists to deal with. It's their problem. It's not my problem. So, here we have a couple of examples. 2 arguments. The first argument is valid, the second is not valid. Can we see why? Well, let's look at argument 1. If it's raining, I'll take my umbrella. It is in fact raining. Therefore, I'll take my umbrella. If you recall, we've already discussed an argument like this in the first video. It says, if R is true, then U will follow. If raining, then umbrella. It is raining, therefore umbrella. I'm saying that umbrella is a consequence of rain. If rain is true, then umbrella will follow. So if that's true and raining is true, then umbrella should follow. Otherwise, one of my premises can't be the case. But it follows, right? The consequence of R is U. R is true, therefore U follows. That's kind of my informal gloss on it. We can prove it in a different way when we start dealing with sentential logic. But we're not there yet. Here's another argument. If he's a communist, he's an atheist. But Richard Dawkins is an atheist, therefore he's a communist. This is not a valid argument. Again, if we just kind of think about the relationship between the moving parts, we can kind of see why. Right? If something is a part of category C, then it's an A. But however, being A doesn't backtrack to category C. Let's find a more easier counterexample, right? If you're a whale, then you're a mammal. I'm a mammal, therefore I'm a whale? Well, that doesn't work, right? Because if C implies A, doesn't mean that A will therefore imply C as a conclusion. All right, so notice what we've done here is that we've reversed the order. So the valid argument says, if R, then U, R, therefore U. The invalid argument has the second term here, A, as the second premise. If C, then A, therefore C. This is called the antecedent, this is called the consequent. So a valid argument, if R, then U, R, therefore U, has the antecedent as the second premise. An invalid argument has the consequent as the second premise, and that doesn't work because the first premise says the consequence of C is A. It doesn't say anything about what the consequence of A would be, and therefore you can't conclude C. So the second argument here is invalid. Again, we're going to develop formal tools to see this. I just want you to kind of understand why the structure of the argument itself doesn't work. Right? If you want, you can stop here and draw like a high school style Venn diagram, right? Where, in fact, why don't we do it together right now? Like, let's see, how do I Alt-Shift W? Here we are. Okay. Now, hopefully you can see the board. Now, the argument says something that all communists are atheists. So imagine this set of all atheists. Now it says that within the set of atheists, all communists are within it. So here's the set of communists. So the set of communists is inside the set of atheists. Now we're going to add. Now we know Richard Dawkins is somewhere in here, because Richard Dawkins is an atheist. But where is Dawkins? Who I'm going to represent, which is the letter D. He could be here without being inside there. Right? He could be in here, but the information in the premises doesn't actually tell us that. All the information in the premises tell us is that Dawkins is an atheist. So he's somewhere in this larger circle here. Now we know all communists are inside this circle, but we don't know whether Dawkins is in here or in here. Well, we know he's somewhere in here. So we don't have enough logical information to determine the conclusion that he's in here. Right? We don't have that. We just know he's somewhere here. This is why it's invalid. However, if we think about the other argument, we see why it's valid. Right? If it's raining, I'll take my umbrella. Well, that's actually kind of a bad example. It's not about category membership. But we see why this one's invalid, at least. Should have rehearsed these more. So, the reason the Dawkins argument is invalid is because the truth of the premises just doesn't guarantee the truth of the conclusion. It's possible that we have true premises and a false conclusion. Right? It could be true that all communists are atheists. It could be true that Richard Dawkins is an atheist. But even if all the premises were true, supposing the premises were true, and they may or may not be, but even if they were, the conclusion still wouldn't follow. Because it's possible that Dawkins is outside of the communist group, but is still an atheist. So the truth of the premises does not guarantee the truth of the conclusion. And this is true generally, because notice I can swap out the content with anything at all, right? Now suppose with atheists I replace mammals and the set of whales, and then I put me. Right? So all whales are mammals, that's true. I'm a mammal. Am I a whale? No, because I'm not necessarily in this set of whales. So what we have here is the important insight that content neutrality shows us which arguments are valid and invalid. An invalid argument is such that the premises could be true while the conclusion is false, while a valid argument says this is not possible. And this is going to be true generally. It's going to be something about the form or the structure of an argument, not about its content, which is a really nice insight, which is what formal logic is interested in developing. So the argument here, premise 1, 2, conclusion that you have here, is generally invalid. It doesn't matter what you replace the variables with, what the content is. It's always going to be invalid. So, gosh, I did the Venn diagram on the board, and it turns out I already bothered making a slide for it. But I'm 10 minutes deep in the video, and you know what? I'm not starting over. So, Another example of an invalid argument is called affirming the consequent. Actually, it's just kind of a different version of the one we've been looking at. So if A, then B, B therefore A, right? That doesn't work. It's possible for the premises to be true and the conclusion false. If the stock market crashes, I'll have no money. I have no money, therefore the stock market must have crashed, right? That's invalid. So a logically valid argument, again, is such that the truth of the premises guarantees a true conclusion. This makes logical validity actually a really narrow concept. In one sense, you can think of it as the conclusion is already implicit in the premises. And the point of a deductive argument, of logically analyzing an argument, is to make what is implicit explicit in the conclusion. If P then Q, P therefore Q, this form is valid. If the premises are true, the conclusion cannot be false, no matter what we fill in P and Q with, right? And in a way, the truth of Q is already there just in the premises by themselves. And I'm going to draw that out a little bit. But the important thing is that this means logic can't possibly be about content, because the conclusion is not something new. It's not something that comes out of nowhere. The conclusion is already implicit in the premises. So logic is not what we call ampliative. It doesn't give us new information about the world. It just tells us what's already true given what we know. Notice that this makes a lot of science not exactly deductive. This is going to be a tremendous simplification of how science actually works, but just bear with me for the purposes of the example. Of course, if you take an advanced philosophy of science class, you might say, well, actually, Hampel's hypothetical deductive method. Okay. But for the point of view of this class, notice that a lot of empirical arguments aren't strictly speaking deductive. So if you look at something like confirmation of a theory by observation, we'd say something like, well, look, if Einstein's theory of general relativity is correct, we're going to observe something called gravitational lensing. What's gravitational lensing? Well, for Einstein, under relativity, massive objects distort space-time, which means light will bend around massive objects. If light is bending, it's kind of akin to what a lens in a telescope might do. So if Einstein is right, we should observe gravitational lensing, which is the bending of light around massive objects such as stars and black holes. So suppose I say, hey, look, Einstein, if you're right, we're going to observe gravitational lensing. I did observe gravitational lensing. Therefore, relativity must be right. You might go, well, wait a minute, this is affirming the consequent. Yeah, and you're not wrong. Scientific argument and empirical confirmation is not exactly deductive. But that's kind of the point. That's not a bug, that's a feature. Science doesn't claim that the truth of the premises guarantees the truth of the conclusion, because science is inductive, not deductive. And that's good, because that always means we can update our theories with new information. So that's actually a really nice feature of science and empirical investigation more generally. It's precisely because we're never quite certain that we're able to improve on our theories with more information. So we're doing a little bit of philosophy for fun here. Karl Popper suggested that, okay, sure, no theory can be definitely proven deductively valid by empirical observation alone. However, what we might be able to do is logically falsify a theory. So now that we have the concept of validity and invalidity clear in our minds, we can actually see the distinction here between empirical confirmation, which looks a little bit like affirming the consequent. Right? So that's why induction is not deductive. Induction doesn't guarantee the truth of the conclusion. But we can use logic, Karl Popper says at least, to show not when a theory is true, but when it's false. So this argument schema is valid. If some theory is true, then X should be true as well. So if Einstein is right, then we should observe gravitational lensing. However, X is not true. We're not observing gravitational lensing. Therefore, theory T is not true. Now, this is a valid argument. If T is true, then X is true, i.e. the truth of T implies the truth of X. However, X is false. Therefore, T has to be false. Because if T were true, then we'd be observing X. We're not observing X. So T can't be true. Now remember, there's only true or false in our kind of logical model right now, and you might make the argument that scientific confirmation is more complicated than that, and okay, but again, this is an intro class, so from the point of view of the logic we have in our pockets right now, we can understand Karl Popper's falsifiability criterion as using the notion of logical validity to show when a theory is false, even though we can never show when it's true. Because if the consequence of a theory is that we should expect to make some observations, and then the observations aren't made, then the theory can't be true as a function, because then the argument here would be that, again, if theory is true, we should make the observation. The consequence of the theory is that we make the observation. We don't see the observation, so the theory can't be true. If it were true, we would see it. Right, so it's kind of the converse of the other argument, right? What was the other argument, right? So if it's raining, I'll have my umbrella. It is raining, so I have my umbrella, right? If are, then you are, therefore you. So falsifiability is logical, but confirmation isn't. It's an interesting distinction. All right, let's do some more logic. Well, I just explained this slide already. So have a look at it, but it's just what I just said. I should have skipped forward a little bit, but again, I'm 16 minutes into this recording. I'm not going to start over. This thing's going to get like 1 billion views. I'm going to be so rich. Okay, so practice exercise 4. Let's test the validity informally of the following arguments. So we pause the video, work on it for a few minutes, and then come back and we'll discuss it. Okay, so here we have either the butler or the maid or the postman did it. Neither the butler or the postman did it, therefore the maid. So we have 3 options here, butler, maid, or postman, but it's not the butler, it's not the postman, leaving only the maid. So the maid did it. Valid argument. If it is a whale, then it is a mammal. It is a mammal, so it must be a whale. Invalid argument. Okay. How do I get rid of draw and zoom here? There we go. I know what I'm doing. So there are 2 ways an argument can go wrong for us. First way, the important one for us, logic students, is that the argument is not valid. The conclusion is not guaranteed. Second way is that the argument is not sound. The premises are in fact false. Now, it's important that we remember we're talking about deductive arguments. Look, of course, there are many arguments that don't guarantee the truth of the conclusion, but we consider them to be more or less acceptable, right? If prior to an election you follow a lot of polls and the polls suggest that a clear candidate, there's a clear winner to the election, and you say, well, I'm willing to bet that, the election will be won by the candidate favored in the polls, that doesn't guarantee the truth of the conclusion, but it's a pretty good argument. It's just not logically valid. For the point of view of this course, however, we're interested in those arguments that are valid. And sometimes we're going to be interested in the soundness as well, but mostly because it's a formal logic class, the formal property here, of course, is validity, not soundness. So, Clinton consistently led Trump in the polls. Therefore, Clinton will win the general election in November. So, this isn't a bad argument. It's not a deductively valid argument, and Clinton, of course, lost. But it's not a bad argument. So, if we tried to make it a valid argument, we'd say something like, whoever leads the polls in the summer will necessarily win the election. Clinton is leading the polls in the summer, therefore Clinton will win the election. Now I've made it valid, but it's not sound, because it's just not true that whoever's leading in the polls will necessarily win the election. Because the polls could be wrong. Because polling doesn't give you the result. The actual election is what gives you the result of an election. So, what's interesting here is that an inductive argument, like our first argument above here, could be considered a good argument because it's based on fairly robust inductive evidence. However, a good inductive argument, again, is not necessarily a deductively valid argument. So these are two rather different things. So we have this notion of validity, we have this notion of soundness. Validity means that the form of the argument is such that the truth of the premises guarantees the truth of the conclusion, whereas soundness is about whether the premises are in fact true. In the argument I had here, said, well, the problem was we had a valid argument with an unsound premise. So we have good inference but false premises, valid and unsound. Valid and sound means good inference and true premises. Invalid but sound would be a bad inference, but the premises happen to be true. What an example of that would be that, for example, remember the argument about communists and atheists and Richard Dawkins? So suppose Richard Dawkins was a secret communist, and you were in fact correct that Richard Dawkins is a communist. Don't sue me, it's just an example. But you're kind of right by accident. The conclusion is right, but it's not because the premises are true. It just happens to all be true. So that's an invalid but sound argument. Invalid and unsound is a bad inference operating under false premises. So not only does the form of the argument not lead to a true conclusion, but the premises are in fact hogwash. So those are kind of the four categories here. Okay, so let's look at this practice example. I want to pause. Work on them for a few minutes, then we're going to talk about them. Did you pause the video? It's awkward. Okay, practice example 5. Valid, invalid, sound, unsound. First argument, if jet fuel can't melt steel beams, fellow kids, then aliens are terrorists. Aliens are terrorists. Therefore, jet fuel can't melt steel beams. So is this a valid argument? No. It's the affirming the consequent form we saw. Right? So if J, then A, therefore J, that doesn't work. And it's also unsound because the premises are false. Aliens aren't terrorists. They're nice people. I know some Martians. Great Martians. Second argument up here, I am a human being. Conclusion, it is not the case that I am not a human being. What does that look like? So just double negation in this case. So I am a human being. It's not the case that I'm not a human being. That's valid. That's sound. The truth of I am a human being guarantees the truth of it's not the case that I'm not a human being. And I am in fact human and not a robot. Either Justin Bieber or Nickelback is the greatest artist of all time. It's not Nickelback, don't be silly. So Justin Bieber is the greatest artist of all time. Valid argument. Either one or the other, not one, therefore it must be the other. Is it sound? I'm pretty sure the premises are false there. But again, you see the difference between validity and soundness in this example. The validity of the argument as a function of the structure of the premises and the conclusion is indisputable. Right? Either one or the other, not one, therefore the other. That's obviously valid. But the premises, I'm sure there are people who actually might think that. How do we know it's sound or unsound? That's a lot harder to prove. But that's kind of the point, and that's why logic is going to be mostly focused on validity. Last argument, some logic professors bike to work. Dr. Nick, that's me, is a logic professor. Dr. Nick bikes to work. So this is a nice example because it's not valid. Right? Some of them do, but the premises don't tell me by themselves whether Dr. Nick, me, is in fact part of that subset that do bike to work. However, I do bike to work often. So it's a sound argument, but it's invalid. The truth of the premises by itself would not guarantee the truth of the conclusion. It happens to be true, but that's just luck. Okay, so one of the things that we often do in a logic class, so if you're taking a logic class right now, is you're probably going to be doing a whole bunch of trying to translate arguments from a language like English, a natural language, into either a formal system, like sentential logic, which we're going to be covering soon, or some kind of pigeon halfway content neutral form where we're keeping the logical language and then replacing the content with variables as we've been doing. So translating arguments and testing validity actually will sometimes be pretty challenging. Words like will allow, as in a stimulus package will allow the U.S. to avoid a depression, are pretty vague. So one way to interpret it would be like it's an implicit if-then claim. If stimulus package, then not depression. So there not being a stimulus doesn't entail a depression if you render it that way, right? So even if it's true that like X causes Y, lack of X does not imply lack of Y because something else could cause it. We haven't ruled a possibility like that out. Right? That's actually kind of an interesting little feature of conditionals here. All right, let me just go over that again. All right. If I say a stimulus package will allow the U.S. to avoid a depression, which is an argument that was made in 2008. There was a big stock market crash, a big housing bubble collapsed, and the argument for a large economic stimulus package was that it will allow the U.S. to avoid a Great Depression and maybe just have like an economic slowdown and recession instead. So the argument here is that a stimulus package allows the U.S. to avoid a depression, but it doesn't necessarily follow from this that not stimulus package will entail itself a depression. The general, right? So the idea is that it's the affirming the consequent argument again, right? So if X causes something, if the stimulus package would cause lack of a depression, not having a stimulus package could also not having a stimulus package doesn't mean there will be a depression because something else could also cause lack of a Great Depression. For example, Elon Musk could suddenly find out a clear, clean, infinite energy source like a Tony Stark arc reactor, and then even though there's no stimulus package, there's no Great Depression, right, because some other external factor avoided it, right? So when we have an if-then statement, what we're saying is purely something about the consequence of the if. If something, that's the consequence. Absent that first part, absent that if, tells us nothing about whether or not the consequence will happen or not. Because it could either be true or false still. Okay, we're going to get back to this one. If you're not quite glomming onto it, I'll come back and talk about if versus only if in a few videos from now. All right. So actually, maybe this slide will help. So if I say, look, if X happens, then Y was the result. Well, not X, therefore not Y. So this argument is actually invalid, and it's important to really understand why. So if I'm saying something like, the outcome of X is Y, and if I don't do X, doesn't mean Y won't happen, necessarily. What I'm saying is that if X is true, then Y will definitely happen. But if X doesn't happen, I'm not sure whether or not Y will happen. It might anyway from some other thing, because there are multiple ways to reach an outcome. It doesn't follow logically that one cause not being present means the effect will always necessarily be absent. So suppose I say something like, man, if I go to the party, I'm going to have some fun tonight. But I can't go to the party. I guess I won't have fun. So that doesn't actually follow. I could have fun some other way, right? So if I go to the party, I'm going to have a lot of fun, but I can't. Why? My car's broken down, so I can't go to the party. But that doesn't mean I can't have fun. Maybe I'll play Xbox, and I had a bunch of fun playing Overwatch. So the fact that I didn't go to the party doesn't mean I won't have fun. What I was only saying was that if I do go to the party, the consequence of that will be fun. But I can't say necessarily that if I don't go to the party, no fun is possible to be had. The if-then structure will be a little bit more transparent when I actually start defining the if and the then in sentential logic in terms of like a binary truth function, which if you don't know what that means, don't worry about it. We're going to get to it. But this kind of abstract reasoning is going to be pretty crucial to understanding the concepts in this course. So even if you don't quite get what's happening, maybe just like stop, rewatch it, think through it again, and you'll see why that the argument here is invalid. Okay, let's just move on because this video is getting a half hour deep. Okay. Here's a practice exercise. If the U.S. economy were in a recession, inflation were running at more than 4%, the value of the U.S. dollar would be falling against major currencies. This is not happening. The dollar continues to be strong, so the U.S. is not in a recession. So what's the argument here? What's the exercise here? Try to translate this argument into a standard form. Use that as a basis to make a content-neutral version, and then see if you can kind of informally evaluate this content-neutral version for validity. And here's a hint. The first premise is actually comprised of 3 distinct statements. Okay, so pause the video, see if you can work on that. Okay, so let's solve practice exercise 6 together. This is a bit of a tricky one. Now, the argument is invalid, but the reason why is a little sophisticated. So let's take a few minutes to look at it properly. First thing we need to do, however, is to identify the premises and the conclusion. Is there a conclusion indicator? The answer is yes. The so at the end there. Conclusion, so the U.S. is not in a recession. The premises are the first 2 statements. So let's translate these, put them in content-neutral form, and see if we can evaluate the validity of the argument. Now again, this argument is logically invalid, and the reason is actually kind of interesting. So let's do it. I have to move the webcam a little bit. Let's bring it over here. All right. Awkward. Okay, so our first premise has 3 statements. It's arranged as an if-then fashion. So premise 1. Roughly it's saying, if recession and inflation, then we would expect a falling currency. Now the trick here on the second premise, all right, so we see the 3 statements here. If the U.S. were in a recession and inflation were higher than 4%, then consequence would be a falling currency. Now the second premise is actually really interesting because it doesn't actually use the same language. It says, but the dollar, this is not the case, the dollar is strong. So you might be tempted to render this premise using a different variable. This would be a mistake because the obvious point is to dispute the truth of one of the statements that are already made. So what we're going to do here is we're going to represent the second premise using the same letter here, the same content-neutral letter that we did in the first premise. Because, again, the point of that second premise is to dispute the truth of one of the statements here. This is one of the ways in which you can kind of find out that how to translate things to content-neutral form and how to find out whether content should be replicated by the same variable. So in this case, it says, but this is not the case, the dollar is strong. But this is not the case is an indicator, again, that we need to dispute the truth of this. So instead of going, the dollar is strong, we're going to say is, no, we're going to go, it's not the case that it's falling because that's clearly what is implied by the dollar is strong. So not the case that F. And the conclusion is therefore not the case that recession. So if R and I, then F, but not F, therefore not R. Now at first glance, this looks a lot like an argument schema we've already looked at together and that we've determined to be valid. It went a bit like this. If X, then Y. 2, but not Y. Therefore, conclusion, not X. Now I said this one is valid. Why is that? Well, it says that if we observe X, we should expect to observe Y. We're not observing Y, therefore we didn't observe X, because if we had observed X, we would have also observed Y. So the falsity of X can be inferred from the falsity of Y. However, I said this argument is invalid. Now why is this argument invalid? Well, the reason is actually kind of interesting. So it is definitely the case that not f here implies that we didn't observe something here, right? But what is, right? If x, then y, not y, therefore not x. What is the x here? It's the whole of r and I. So if r and I together were true, then f, not f. So what can I say here as a real conclusion? My real conclusion would be, it is not the case that r and I are together, both true simultaneously. Which of them isn't true? Well, that actually the premises don't say. It could be not r, or it could be not I, but I don't or it could be both, but I don't necessarily know which one, and that's the interesting thing. The argument's invalid because the conclusion is too specific relative to the information in the premises, because it's saying, if both these things are true, then we should observe f. We didn't observe f. Therefore, it is not the case that both of these are true. But if it's not the case that both are true, which one specifically is the one that's not true? That I don't know. That's actually not there in the argument, in the premises. So the conclusion, not r, is too specific. I actually don't have that information in the argument. So it's an invalid argument because r could be true. It's possible to have true premises and a false conclusion. Right? When we get back and do some sentential logic, that is, when we have some formal tools that are disposed to prove statements, going back to this argument and seeing why would actually be a really interesting exercise. Right now, I really want you to kind of understand informally what happened here, which is, right, this schema is valid. If x, then y, not y, therefore not x. But here, if I substitute if x, then y, not y, not x, but these two statements aren't the same. Here x was r and I, and here I have just not r. A valid argument would be not r and I. Right? Now I have a valid argument because that's the actual thing that's not true. But just not r, too specific. It's not actually there in the premises, and that's why this is an invalid argument. Okay. So this is kind of the essence of logic. You might think this was kind of a nitpicky example, but that's exactly the point. The idea in logic here is to figure out exactly what information is present in the premises in order to make it explicit in the conclusion. If you ever played Minesweeper, you're kind of familiar with this process already. Only 90s kids will remember. In Minesweeper, the numbers here indicate how many undiscovered mines there are in squares adjacent to the number. So here I have an arrow pointing to the square here. And you have the number 1 here. Now look at this number 1. The game itself is a sequence of logical deductive inference. I can deduce there's a mine where the red arrow is pointing because I know there's one mine next to this number 1 here, and the only square possible where it could be is this one. All the other ones have been cleared. We know there's one mine, there's only one non-empty square where it could be. So there's a sense in which the conclusion, there must be a mine there, is already implicit in the premises, and I'm just making it explicit. Why? Because logically speaking, there's nowhere else it could be. The information in the premise, represented here by the number 1 in Minesweeper, already tells me where the mine is. And my logical deduction is merely making that information explicit. And that's the whole point of logical deduction. I have information in premises. That information is structural. And I am going to make explicit exactly how much information is hidden in that premise. But I'm not adding new information. I'm merely revealing, making explicit the information that's already there in the premise. And that's what makes it a deductively valid argument, or an invalid argument. If an invalid argument is saying something that goes beyond the information in the premises, like the argument we just did. Why was it invalid? The conclusion was too specific. The valid conclusion would have been not both R and I. The conclusion was just not R. That's too specific. That's not B-roll. It's an internet joke. All right. 40 minutes. This is getting to be a very long set of videos. So we've been evaluating arguments the way we've been doing it kind of intuitively, using informal reasoning, just walking through them with my help. And that works kind of well enough. But what we're going to be doing soon is introducing formal tools that allow for this process with a high degree of precision, consistency, and completeness. Now, we'll just use an example of Minesweeper. Could you write a program that plays Minesweeper? Sure, people have. You could write a rule, for example, like if there's only one non-empty square adjacent to a 1, then that's necessarily a mine. That would be a good rule. And likewise, what we're going to be doing soon is we're going to determine the validity of content-neutral arguments using similar rules, rules that a computer could implement. But that's going to be for another chapter. For now, what you should be doing is going to Chapter 2.2 and looking at pages 34, 36, if your pagination is the same as mine. Otherwise, choose arguments from sections A, B, C, and D, put them in content-neutral form, decide whether they're valid, try to explain your reasoning. All right. Thanks very much for listening. I'll see you in the next video.